Good morning, everyone. Good afternoon, depending on where you are. Welcome to this session about Micronaut and GraalVM. My name is Alvaro Sanchez. I'm quickly presenting myself. So I'm coming from Madrid, Spain. I've been a developer since a few years ago, always in the Java ecosystem. I'm working on Micronaut since the beginning. The main areas where I work are the Maven support, a few other modules that I wrote, for example, cloud object storage, Kubernetes, cache. So I'm currently working at Oracle Labs, in which I work not only with Micronaut, but also the GraalVM native build tools, which are plugins for both Maven and Gradle for using GraalVM. We're working on a new product called GCN, Graal Native, which will be announced in the following weeks. And as a speaker, I like to go to different conferences to speak about all things Java Micronaut. And on a personal level, I'm married, have 2 kids, so that's me. So I'm gonna talk to you about several things. One is the general introduction about Micronaut, what it is and how you can use it. Then I will talk specifically about the Kubernetes support in Micronaut. And finally, I will mention some notes about GraalVM integration, what it is and how can you use it. So Micronaut, for those who never heard about it, there are like 3 main ideas I would like you to get out of this presentation. The first one is that Micronaut is a modern Java framework, and by modern I mean that it was designed in 2017, and that's really important because we could focus on the type of applications that were developed in the recent years, right? So microservices, serverless, and cloud deployments. And never of this was existing, like 20 years ago, if you compare these to other frameworks like Jacquard or Spring or whatever. The second idea is that you can use Micronaut for all application types. People use it typically for writing microservices like REST APIs, but you could use it for anything else, like, for example, message-driven applications where there's no HTTP server listening, like a Kafka consumer producer, or even command line apps, serverless functions, whatever. The third idea is that is highly optimized for performance, and I will explain later in the next slide how that works. But essentially, we have invested a lot on making the framework with a very low startup time and a very low memory consumption. And the way we do that is using something called AOT, ahead of time. The idea is that we use a Java facility called annotation processor tool, APT. With APT, we generate build time all what the framework needs. So the core of the framework is a dependency injection framework, and we have, you'll see that later, but we have the typical annotations to do dependency injection and everything like that. So as an annotation-based framework, we compute all the infrastructure, all the all the necessary bins, the metadata, AOP proxies at build time, as opposed to, for example, doing that at runtime. So at runtime, there's no reflection, there's no proxy generation, no dynamic class loading. We don't scan your class paths nor your dependencies class path. So at runtime, everything is much faster. As as an idea, you can use Micronaut for anything with Java, Groovy, or Kotlin as languages, any build tool, any cloud, any testing framework. A bit of history. So the framework was first created in 2017, with the first release in October 2018. We attempt to release a major version every 1 year, more or less, and minors and patch releases with that cadence. We take semantic versioning very seriously, so that we want to bring stability and smooth upgrade paths to your builds. The current version is 3.7.0, and we're targeting Micronaut 4 for the next quarter. Actually, by the end of next quarter, you can expect Micronaut 4. And because it's a new major version, we will take the opportunity to refactor some things that may produce breaking changes, and we'll explain that accordingly in the release notes. So let's see a quick overview of the features of the framework. So the core, as I mentioned, is a dependency injection mechanism. So you can use standard annotations or even Spring ones. As a side note, the Spring support is extensive. So we not only support Spring DI annotations, but also most of the MVC and other annotations, with the idea that if you take an existing Spring application or a Spring-based component and add a micro dependency, like essentially the notation processor and the class path, we compute we essentially do a translation of the Spring annotations at build time into the Micronaut counterparts. So you could take a Spring annotation and run it with Micronaut runtime. For configuration, there are several formats supported. There is a built-in validation support, which is reflection-free, faster, and really small, good for native images. But if you need full Beam validation API compliance, you can use Hibernate validation, which is also supported. There is an AOP framework inside Micronaut that you can use as well. And again, the difference is that it's compile time and reflection free. The hello world would be something like this. So the programming model is typically annotation based. So for those using Spring, they would feel at home with Micronaut. There is normally an equivalence between the Spring annotations and the Micronaut annotations. So we try to not reinvent the wheel as much as we could. Yeah, this is like a sample crash controller with an endpoint. The previous one was for producing an HTTP server. To produce an HTTP client, we have a client annotation. You're going to start to see here, for example, in this case, this interface is going to be implemented at compile time. So the actual method implementation to make an HTTP client call to a server will be generated at compile time, so that at runtime there's no framework overhead at all. For message-driven applications, we support the major technologies. For data access, there is one module of the framework called Micronaut Data. Micronaut Data supports not only JDBC, but also RTDBC, so you can connect it essentially to anything. And there are two flavors. One is Micronaut Data JDBC, and the other one is Micronaut Data JPA. It is again annotation based, so it follows the repository pattern. You can see this pattern in other frameworks, like for example, Spring Data. The difference again here is that everything is implemented at compile time. So we compute the queries at build time based on the dialect, which is specified here, based on the method name, and you can always have the ability to customize anything, like introduce custom queries, or even there is an API where you can programmatically run anything you want. So the level of customization is up to you. In terms of security, we essentially got you covered. So there's was to supported. The security rules are normally annotation based, that you can also define them via configuration. There are authentication strategies for all the major technologies, namely JWT, but also certificates, HTTP session, etc. And in terms of falsehood, there's like plenty of support and integrations with major providers. And there's much more, like distributed tracing, cyber discovery, distributed configuration. So essentially all the 12-factor patterns are supportive, monitoring, API development, etc. How to get started? So there are several ways. One is using Micronaut Launch, which is a website where you can select the several parameters, like the type of application, Java version, and then build tool, test framework language. In the future, you will be able to select the cloud provider where you want to deploy that, and then select the features that you want to include in your application. For example, you could say that you want an application with Micronaut Data JDBC and I don't know, the Oracle database. And so based on the features you select, where the application generated will have the necessary dependencies and configuration. And from there you can preview, you can download it, you can push it to GitHub from this UI as well, wherever you want. There is the possibility to download CLI and run this locally, right? So if you're more comfortable with a terminal, you could do that. But the CLI, essentially all the mechanisms you will see here are different front ends for the same backend. If you use IntelliJ IDEA has a wizard for generating Micronaut applications. But like I said, this is different front end for the same backend. And finally, for Visual Studio Code users, there is an extension called GraalVM extension pack, which includes Micronaut tools that helps you not only creating Micronaut applications, but also with other features like generating native images, deploying to different targets, etc. There is a demo about Micronaut, but I will leave it at for the end, just in case we run out of time, because there are more things I would like to explain. The next part is about Kubernetes support. So one of the features that the Kubernetes integration provides is service discovery. So with service discovery, imagine you have an application that needs to make a request to one Kubernetes service. So without Micronaut support, you could do that. You could specify essentially the service name, but then this will work because within Kubernetes there will be like a DNS entry for the service, but you will still have to provide like the protocol and the port manually, which is problematic. And this also wouldn't work if you have like different replicas or different replicas on different ports or something like that, right? So if you use the Kubernetes integration, then the only thing you need to care about is the service ID. And Micronaut internally will query the Kubernetes API to figure out the endpoints in which that Kubernetes service is listening. Yeah, so this is essentially an explanation of what I just said. Another feature is distributed configuration. The idea is that you can use Kubernetes config maps and secrets to store configuration information, and then you can inject it in your application with different ways. One is, for example, using the add value annotation, but there are others, like for example, using a configuration properties class to have a type safe configuration binding. There are different ways. So you can have programmatic API to retrieve configuration values, and they all can come from both config maps and secrets. So we not only if you allow this to work with the Kubernetes API, so if your Micronaut application deployed on Kubernetes has permissions to query config maps and secrets, we will by default watch for changes in them. So you could potentially make a change in the config map and then refresh your application, and without any restart, it will have the new value. If for whatever reason you don't want the application to have Kubernetes API access, you can mount the config maps or secrets as volumes, which will be essentially files in the file system in the pod, and Micronaut will read them as well. Another thing that provides you the Micronaut integration is health checks, if you enable it, with essentially proving communication with the Kubernetes API, additional information about the pod where the application is running, and then information about the service discovery. There is integration with the official Kubernetes Java client. So you can, we have factories for all the Kubernetes APIs clients. So you can inject any of them as a dependency in your beans. So in this case, we have a class which is annotated with a singleton, meaning it's a bean, and you can inject. In this case, is a core V1 API, is a official Kubernetes client dependency, and we will inject that for you. You can customize the underlying HTTP client. We have a wrapper using reactive types with Reactor and ArcJava 2 and 3. So there are many options around this. And the final thing is Kubernetes Operator support. So you can implement Kubernetes operators in Java using the following building blocks. You can implement informers, reconcilers, and essentially leader election algorithm for both core and custom resource definitions. The first building block is the informer. So the informer is like like a way to get notified when a Kubernetes type is changing, right? For example, what I mentioned before about watching for config map changes is internally implemented as an informer. It's really easy, it's annotation based, and we will take care of all the wiring under the covers. And the other facility is a reconciler for more complex scenarios, where you not only watch for changes, but also have to like to implement a reconciliation algorithm. And the final section is about GraalVM. So GraalVM is essentially it's many things, but you can think of it as a drop-in replacement for the JDK. Currently is Java 11 and 17 only. But also it can be used to create standalone binaries. So there are like two paths you can take with GraalVM. One is to take an existing Java application and then use it as a regular JDK to run it with JIT mode. So GraalVM is actually an OpenJDK distribution, fully compatible. And then the other path is use AOT instead of JIT and produce a native image, which is like a binary for the operating system where you're running this. Micronaut and GraalVM is a good combination because it gives you really low startup times and really low memory footprint with better throughput in different scenarios. And Micronaut and GraalVM is also the best integration possibly because both teams are working together at Oracle Labs. So you won't be able to find any better integration of GraalVM with Java framework than in Micronaut. And there is also the ability to have GraalVM EE, the Enterprise Edition, which is included for free in Oracle Cloud and offers advanced features like presence commercial support for Java 8 and things like that. Micronaut is ready for GraalVM native image since day one because the design of the framework includes no reflection, no runtime proxies, no bytecode generation, anything. So we were the first framework essentially to be GraalVM native compatible. And then, like I said, the GraalVM extension pack, which includes help to work with both GraalVM and Micronaut, is written and maintained also internally at Oracle Labs. The way to produce native image, depending on the build tool you use, so you can essentially produce a native image locally, and that will give you a binary for the operating system where you're running this command for your local machine, essentially. And the alternative is to use Docker packaging or Docker native image, in which we build the native image inside a Linux Docker container. And you get essentially a Docker image that is running instead of a Java -jar of your application is running the native binary. Okay, so we have 6 minutes left, and I'll try to do some live coding if I can. So a Micronaut application is a regular Gradle application. What I'm going to do here is essentially to create a, well, this is an empty application. It has like a typical main method. The only thing that I did beforehand is to include Flyway to create a database table and some data inside. But other than that, it's an empty application. So I'm going to create a class, and then I'm going to copy everything because I don't have time to type. So this is like an entity. I'm using JPA annotations, as you can see. And the other thing I'm going to create is a repository. And again, I'm going to copy this. So this is actually an interface. I'm using H2 locally. And we're extending Crack repository, which offers me like the CRUD operation, like save, find, PyID, etc. And the last thing I'm going to create is a controller, REST controller, with a couple of endpoints. One is to list all the elements, like to list all the teams. So I didn't mention, but this is mapping like a football team or soccer team, if you prefer that, with a couple of attributes, name and stadium, and a couple of endpoints. So I can run this. For example, I can go to the main class and run this. And of course, the demo gods are not with me, but don't worry because I have a plan B. And this is this solution, where essentially I copied from. So I will actually use the terminal. 2 minutes left. Right, so this is running and it's using Flyway to do the migration, to essentially create the schema and insert some data inside. And everything took like half a second. And then I make a request and get some data. I can make get one team and it works. Everything works. And the final thing that I want to show you is same thing, but running from a native image. So I generated the native image beforehand. It takes less than 1 minute to build it, but I have like 1 minute left, so I'm not gonna use it for that. But instead, I will run the local version I have here. So it took. Let me try again. I don't know if you can see this, but this 29 milliseconds to start the application with an embedded H2 database, Flyway migrations and everything. So it's really impressive. Yeah, that's essentially my presentation. So I think we have time for Q&A. Is Micronaut similar to Spring? Yes. So in a way, it is. It can be compared to Spring and Quarkus and Jakarta IE. So it's a general Java framework. And the main difference is what I explained before. So Spring tends to compute all the framework infrastructure at runtime, whereas Micronaut is the only framework approaching build time or ahead of time compilation. So that's the main difference. Any other question? The code window has too small font. Yeah, I will share the. So this is my Twitter handle. So I will share a link with both the presentation and a GitHub repository where I have the code. So don't worry about that. What is the main difference and why should I prefer Micronaut over Spring? So I think it really depends on the team knowledge and and also it may depend on, for example, if you're deploying to the cloud or you are using especially serverless deployments, there's a big difference because of the runtime performance of the framework, essentially startup time. So it's a Micronaut function in AWS Lambda will start much faster than anything, any other framework, or at least compared to Spring. That is one big difference. Other than that, so the frameworks are similar. So we're trying to provide like a similar programming experience. So they are both based on notations. I'm obviously biased, as you can imagine, but I think working with Micronaut is better. It feels better for the developer because of the startup time. So, for example, writing tests is like several orders of magnitude faster with Micronaut because of the startup time. So you normally no longer write like a lot of unit tests and then very few integration tests. But instead, you can write functional tests that spin an instance of your application in a random port, and then you can grab an HTTP client against that instance of your application, and make REST API calls and assertions on that. So doing that is a matter of milliseconds. Is really fast, so the testing experience is really nice. You can write functional tests, you can inject your beans in your test, and everything is fast. So I think that makes a difference. Yeah, other than that, yeah, do your research and choose. I must say that both are great frameworks, and obviously Spring is the market leader, and it's basically Spring changed the way we create applications, but well, it's no longer 2000, so it's 20 years since Spring was created, and I think there are, at least there are new alternatives, and that's great because competition is great for everyone. No more questions. All righty. So thank you very much. I hope you enjoyed this presentation, and I hope to see you either on Twitter or in person in another conference. Thank you very much.